Well, if you're here, you're probably here because you want to share libraries, or at least you're thinking about it, and that's good because we should share. I mean, the world is better if we share, and it's obviously much better for the Scala ecosystem if we share our code as well, right? So sharing libraries is a wonderful thing to do. At The Guardian, we have a lot of libraries. We have about 40 of them, and we don't have a monorepo. So this is actually kind of how our different teams, our dozens of different teams, expose their functionality to other teams. So they have APIs and they have clients for talking to those APIs. Those are given as libraries. We also have shared infrastructure and security code, and we also have just common general code that is kind of cool and useful and generally useful to the outside world. So we publish quite a lot of open source libraries as well. So we've been doing that for a long time. Last year in 2023, we've been doing it for a decade. We've been publishing to Maven Central because it is like the de facto place to publish artifacts to. And the Maven Central is run by Sonatype, who give you a server to push your artifacts to called oss.sonatype.org. And this whole arrangement is kind of free for open source projects. It was really nice. We don't have to run our own artifact repository. But on the other hand, it can be quite slow publishing things into Maven Central. And in fact, last year, after having been doing this for 10 years, there was still two quite significant problems, which was that it was both difficult and dangerous, which is two pretty major problems to have with the way you work. So the reason it was difficult was because to push to Maven Central, to push to oss.sonatype.org, you need a quite complicated set of credentials. You need credentials with Sonatype. You get those authorized to push to your Maven coordinate by opening a ticket in Jira, which is eventually answered by a human being. And as well as those Sonatype credentials, you also need PGP credentials to sign all the artifacts you put up. That's one of the requirements of Maven Central. And that's all sort of reasonable. But actually, when a developer's working on a team, they suddenly need to upgrade a library, it's quite likely that they haven't even heard of PGP. That's normal for a lot of developers. I've not heard of it. And setting up a PGP key is a pain. You have to publish it to a key server if you can find a working one. It's a drag. And then the actual the process that we were more or less commonly using across The Guardian for publishing was using SBT release, which is a nice plugin, running on developer laptops. So that is quite a manual process, and there is a certain uncontrolled nature to developers' laptops. They install all sorts of software that they're not necessarily the most controlled environment. And some teams have been looking at trying to address this by using automated CI release, right? And the sort of individual teams have been kind of experimenting on this, but there was no standardized way of doing it. And a lot of people were creating quite large YAML scripts that could do things like publish beta versions or publish snapshot versions. And there was just lots of YAML and bash being copied and pasted everywhere, and then not quite sort of tuned into a standard that we were using across the board. So, and this is a bad thing, right? There is a range of different languages used in The Guardian. Scala is one of them, and we don't want the first experience of a developer trying to deal with sharing their Scala code to be a negative one. We want them to be as smooth and easy as possible, and so that was a concern. So that's the difficulty of publishing to Maven Central, having to get these credentials, having to authorize them, all of this stuff, and also having a nice standard process that you could use that you wouldn't have to teach someone every time they came to a new project. But the project, it wasn't just, the problem wasn't just of difficulty, there was also danger, right? And the danger comes from binary incompatibility, which sounds quite innocent, but it's not. It's hideous and dangerous and comes for you in the night and crashes your server randomly at random times when you are not expecting it. So you can do all the unit testing you can do integration tests, but you can't necessarily guard against binary incompatibility by testing. I had an experience of this where I wanted to upgrade a library to do with saying what stories are on the front page of our website. So there was a fronts API, we call it the FAPI client. Oh, is the microphone off? Sorry, what happened there? No, it's actually gone off, I think. I think it's died. Do you want to swap?
Try this one.
Thanks. How's this? Yeah, thanks. That's great. So you just watch this for me and tell me if this goes out. Okay, thank you. So I wanted to upgrade this fronts API client library. And I had some big changes I wanted to make. And I thought, before I do these big scary changes, I'm going to do a really minor change, pushing out these few point releases, and I'll just get that out of the way nice and clean so that I can concentrate on my big change and then release that later on, and we'll know if any problems happen that it's to do with my big change. So I make the change to the library. I released the new version. I still remember the version number. It's blazoned on my soul. It was version 4.0.6. And I was like, yeah, this is just a minor patch change. This is not dangerous. So this library is used in maybe 7 different live services at The Guardian. So I roll it out to a few of them. Everything goes fine. Everything's great. I roll it out to quite an important tool, which is literally the tool that editors use to put stories onto The Guardian's website. And it's all fine. And then maybe 7 or 8 hours later, the servers just start to die. This tool just starts to die completely, goes down, dead as a doornail. Just randomly. And I'm like, how did I do that? What happened? And it turned out that it was binary incompatibility at the root of it. So if we have a look, dangerous, yeah. So if we have a look at the app server, so the app server is running all this code, and I had upgraded the FAPI client there. And that meant that I had a slightly new version of the content-API client, which depended on this library here, content-API model Scala, and it depended on 17.5.2. But the app server itself also directly depended on this JSON library, and that depended on 17.5.1. So a pretty minor patch version difference, right? Now, what was happening was, in the tool that let people put things onto the website, there was a little search bar. And in the search bar, you could search for stories you want to put on there. So you might want to search for cats. Give me stories about cats. Or give me stories about the environment, stuff like that. Now, most of the time, this search was working just fine, just peachy, completely great. But after about 8 hours, someone did a search that just happened in the results to include a podcast. A podcast came back in the results. Now, it just turned out that in the change to the content model between those two versions, an additional optional field had been added to podcast. And so this library here, the JSON library, is attempting to deserialize a podcast, and is attempting to call a constructor. But it has been compiled with a constructor that has 10 parameters. And the library now is being used with 11 constructors. That's what's actually in our runtime. And so it cannot work. It will fail. And it fails on this random occurrence of someone returning a search result that happens amongst that page to include a podcast. So there's that extra field. This is actually thrift, but Scala classes was derived from this. And this is the error. This is a linkage error. No such method error. Horrible runtime error, and it completely killed the server. I'm not entirely sure why the server died quite as heavily as it did, but it definitely did. So yeah, you can see that the JSON library is trying to call the Scala model, and there's basically, really horrible error, disgusting to look at, basically the wrong number of parameters. A pain. A random, awful pain. And so I thought about this for a while, and I was like, is there any way I could have guarded against this? If I'd written a unit test testing the deserialization of podcasts, would I have been okay? And I was like, we have lots of different content types, not just podcasts. We have lots, dozens. Would I have to write a test for each and every one of them? And what if the model change had been buried deeper down in the model? What if it had been some subfield of a subfield? Like, would I write a test for every single subfield? Some of these are really obscure. They're not used by editorial very often at The Guardian, so it's quite hard getting good sample data for them. I couldn't think of a good strategy for unit testing my way out of this. What I needed was a way to make sure that binary incompatibilities couldn't happen in our libraries. I needed to do that somehow. So that was the state of things in 2023. We had two problems. It was difficult and it was dangerous. And so what can we do? What can we do about that? Well, let's start with the dangerous part. So the danger is coming from the binary incompatibility, right? And it turns out that SBT has for a long time had eviction warnings that warn you when one version is getting evicted, but they're just warnings. So, like, here's an example warning, and you can see that it says warn, right? It says warn, because the thing is that, like, technically this might be useful information, but the truth is that SBT doesn't have enough information to know what's going on. It can't guarantee that this is actually a bad thing, and so it's just warning you, and you are ignoring it because you're busy. So why doesn't it know enough information? Well, the reason is, here's a version number, right? XYZ. And if I bump that middle Y there, what is that?
Minor.
Oh yeah, well, maybe, okay. Is it source compatible? Is it binary compatible? Okay, so yes, your instinct is very good, but the problem is that as far as SBT is concerned, as far as like the ecosystem is concerned, people at that point had not standardized on what version numbers meant. There were actually two popular standards in place, and there were several other ones as well. So these are the two popular standards within the Scala sphere. So Semver, which is very well known. Everyone knows about Semver, major, minor, patch, yeah. But also, a lot of Scala engineers were using this. I think the actual Scala library itself uses this. Epoch, major, minor. And so PVB, I can't remember why, but this is like from the Haskell community. They like this. And so if SBT sees a library and sees a version bump on that Y, it doesn't know if it's a minor update or a major update. And even then, there is perhaps some ambiguity about what qualifies as a minor update, what qualifies as a major. And so SBT introduced a series of things related to this. In particular, it introduced the version scheme setting. You've probably seen people complaining about this. So version scheme lets a library say what its version scheme is, what its numbers mean. Like, is it doing this one or is it doing this one? Okay, so it lets you say, actually, you know what? I'm using Semver. And furthermore, at the same time, they came up with a bunch of recommendations, whoa, so much text, a recommended versioning scheme for Scala projects. So there's a fairly strong recommendation that you should use Semver, major, minor, patch, and then these are the rules for when you should increment those different numbers. So binary incompatibility, that's the worst. You've got to increment major. Source compatibility, that's minor. Patch, that just means you're doing a bug fix or whatever. So those are the rules. Technically speaking then, we've got three things to do to get to a happier place where binary incompatibility is gone and the danger is destroyed. Okay, three things. Use SBT 1.5. I guess everyone's doing this. Everyone's got SBT 1.5 by now, probably. So that's easy. We need to add a version scheme to our libraries. So just saying, we're using Semver. Easy. Then the hard bit, we've got to use version numbers that respect compatibility. And that is hard. That is hard because human beings can't do it. We cannot do it. I've been looking at this for a while, and I can barely quote to you the definition of what binary and source incompatibility means. And even more than that, like what are they affected by? So technically speaking, I'm going to try and do this from memory. Binary incompatibility. Binary compatibility means that you could take a binary at one version, replace it with a binary at another version, and the code will still run without misfix. So one compiled artifact can be replaced by another compiled artifact. They're binary compatible. If the code at a particular version can compile, then that's source incompatibility. That's source compatibility. Blah, 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 blah. Anyway, right, so, okay, great. So how do we achieve like binary compatibility in Scala? When have we broken it? So there's a nice repository by Jacob called the Binary Compatibility Guide. And he gives a whole bunch of examples of things that can break binary compatibility. And the list gets, terrifying. So, okay, fair enough. First item on the call is mark methods as package private when breaking API changes. Okay, so that's a nice trick. You can do that if you want to make a breaking API change. Great. Second one, don't add parameters with default values to methods. Okay, so that's actually kind of what we fell foul of in the FAPI client, because we'd added a new optional parameter. The default value was none, but that wasn't enough to save us as far as binary compatibility was concerned. And then the third one is the one where I'm like, I've given up hope. Avoid case classes. But I really like case classes. I don't want to give up case classes, they're cool. And he has a whole bunch of perfectly valid technical reasons why, as you modify case classes, you will break binary compatibility. Okay, well, you know what, in that case, I think sometimes I'm going to be breaking binary compatibility. I have to live with that, and I want to know about it. I need to know when I'm doing that, and I'm not going to be able to work it out for myself. I don't want to spend time thinking about it. What this means is human beings should not pick version numbers. We're not good at it. We shouldn't do it, and we definitely don't understand compatibility. It's too hard. I'm not going to go around thinking how many fields I have in a case class. I don't want to. Which means that we need to get a computer to do it for us. And that's where this plugin comes in. This was released maybe a year or two ago, SBT version policy by the Scala Center. A great plugin. So this does a whole bunch of stuff. It uses MIMA and analysis of your dependency tree to work out your code as it currently is compared to the last published artifact you ever had, the latest artifact you published. What is the level of compatibility between them? Are they binary compatible, source compatible? And it can automate that process, which is great. The way you use it was not so great for us, because what you would do in your library, you would set a parameter, the parameter called version compatibility intention, and you would say something like, I want this code to always be binary compatible, or I always want it to be source and binary compatible. And then version policy check would just crash your CI, would kill your CI if you ever did anything that wasn't binary compatible or broke compatibility beyond what you said you would tolerate. So the reason that wasn't suitable for the Guardian is that kind of like, we do just want to like add in methods and functions, whatever the business needs. We want to be able to break binary compatibility. We don't want to be constrained, but we do want to know when we break binary compatibility, and we do want the version number to be correctly incremented to reflect that, so that SBT can do all of its sensible stuff about blocking bad incompatible versions being in the same JVM. This is actually really nice because SBT version policy didn't have that functionality, and I wasn't confident that I could make the changes to this code base to put it in place, but we were able at The Guardian to hire one of the core contributors to this plugin, Julian Richard Foy, to make the changes for us. And so we worked together for about a week on getting those changes in place with this new mode of working for the SBT version policy plugin. And that was really nice to like sponsor some open source and get the functionality we wanted. So now it has this new superpower that it can, well, actually, just look at the length of this method name. It's a very long method name, but all of this functionality boils down to this single method here, right? So you add this to your SBT file, your build SBT file, and you say, when you release call this method to work out what the new version number should be. I did talk to Julian about shortening the method name, but he didn't want to. So this is good. So what we've got is now a tool that can get us out of this whole danger, the binary incompatibility danger of having lots of library versions. That's nice. I guess the problem is that we've got a lot of repositories, we've got a lot of libraries, and we would have to roll this change out to all of them. We have to include the SBT version policy plugin. We've got to add this bit of config. We've got to educate the developers about what this thing means, about the fact that they're no longer choosing version numbers, that the version numbers are being chosen for them. And we've got to get them all to do a release. And then we've got to get everyone to upgrade to those releases so that they're now using the versions that declare themselves to use a particular SEMVer versioning scheme, and they have correct and sensible version numbers. So it's quite a lot of work. And the truth is that while this is really useful and makes everyone safer, it's not particularly exciting. It's like, this is good, but like the prospect of doing like 40 pull requests across like all these different repositories just for this benefit it's like, yeah, we should do it, but it doesn't really sell itself. So we want to pull in some more benefits to make this a more compelling change so that people are going to get onto this faster. So given that, let's look at the other bit, the difficulty, and also another danger. So the danger I'm referring to, I was thinking, the difficulty comes a lot from the fact that we haven't standardized on a good approach for releasing our libraries through CI. We need to make it like a push button operation, and right now it's a very manual operation happening on developers' laptops. So okay, we need to standardize on some kind of GitHub action situation that is going to release our CI for us, and everyone will like that much better. Also, we're going to need a single shared credential for the PGP key and for the Sonatype credential, so that developers don't need to get their own ones. So that's all good. But I was a bit concerned about how that credential was going to be exposed. If we look at the steps of a release, these are more or less what happens during a release. You compile and test the code, you set a version number, commit that change to Git, you create the actual jars from the class files, and then you sign them, you upload the artifact jars to Sonatype, and you push all the changes and tags to GitHub. So the thing is, a lot of these steps kind of require you to be using the libraries, all the libraries dependencies, right? You're pulling in all the plugins that Build SBT is using. You're also running the tests, and the tests are loading all the classes from like the dependencies. And so the fact is that it's not very hard to write a bit of code that when a class is loaded, it immediately grabs all of the environment variables and sends them to paste bin, just like to some malware place, right? It's not hard to write reasonably subtle malware that can just extract all your credentials and conceivably also do privileged actions. Because if you look at some of these actions, there's some fairly privileged things going on here. You have got access to a private PGP signing key. You're able to push stuff to GitHub, and you're able to upload stuff to Sonatype. And if you can upload to Sonatype, you can like publish a new version of one of our Guardian libraries that is full of malware. You can spread malware further. So we've got a lot of code that is including a lot of dependencies, like for any given library, lots of exciting and unusual dependencies that, like for one project, one library, yeah, okay, so probably there's nothing hiding in that particular one library's dependencies. But if you think about that, we've got like 40 different libraries, all pulling in different exciting and exotic things. The odds start to get worse and worse. And I didn't like that. So let's just look at the breakdown of these stages here. So if we look at the two stages that are running the code that is controlled by the library, pulling in all the dependencies that the library needs to run its tests, there are these two. And I'm using the confetti ball emoji to denote those, because basically, this is what is happening with the dependencies, right? We've got this lovely project, and out of it are falling all of these glorious dependencies, and there's glitter and excitement and functionality, all the things we want. But the truth is, we don't really know what's inside the glitter ball. We don't know what's going on. We're having a party, it's all a fun time, but we don't actually really know what's all in all of those hundreds of different dependencies that are pulled in to build our project. So we have two glitterable party stages, the compile and test stage, which is using build SBT and pulling in the dependencies, and then also create the artifact jars, which uses the publish action, which again is using the build SBT file. So we can look at that, and then we can also look at this. So with a lock, I've marked the ones that need privileges, and they are disjoint. They are not the same, right? There's the party code, and there's the privilege code, and they don't actually overlap. So we can achieve isolation here. We can do better than have everything running in a single JVM process. If everything runs in a single JVM process, there's not really any isolation. The code that does the compile and test can also access the credentials, can also push things to GitHub. There is no proper secure separation. But we can, given the way these things break down, we can separate them. Now, we can, in GitHub Actions, you can make a custom GitHub action. That can't really do more than one virtual container, but there's also a thing called reusable workflows. And every step in a GitHub workflow is what's called a job, and that is an isolated virtual runner. It's an isolated machine, its own container. It is completely isolated from all the other jobs, except for the values that you choose to pass on from one stage to the next. I can't remember what my next slide is. Oh, found that. Okay, yeah, so we can define a reusable workflow that can be used for all of our projects that breaks the publication task, the release task down into jobs. So let me show you what that looks like by doing a release now. Okay, so here's one of our libraries, etag-caching. That's a nice library, and we've got a pull request here that's been generated by Scar Steward. Okay, so I'm going to merge that. Okay, so now I want to do a release. And like, you know, sometimes I don't necessarily want to do a release straight away. Like if I was editing a README file or something, I don't really feel that warrants making a release. But now I've decided, yeah, let's make a release and let's do it nice and easy. So we go to the release workflow and we run the workflow. And it kicks off. And so now we can see the isolated jobs that are going to be the stages of the release. And so the first job is like a secure, trusted job. It's just doing some initialization. It's working out what kind of release we're trying to do. The next step is one of those party confetti ones. So here it's running the test, it's compiling the code, it's running the tests. It's also got the job of running that SBT command to work out what the next version number should be. So it's doing the assessment of compatibility. So one of the outputs of this step, which will take a minute or so, is to work out what the version number should be. The next step is a secure one where we push the release commit that's got that version number in it. We push it off to a temporary branch. So like supposing this release aborts halfway through and fails, we haven't actually committed to the main branch. We try and delay that as late as possible. And then we create the artifacts. That's when we take the class files, we stick them into jars. And again, this is like party code because we're trusting the library's build SBT and all its dependencies. And that's passed on to the next step, which will sign them. If only there was good zoom on this thing. Oh yeah, it's like that. Right, so the next step is a privilege step. It will sign them. It will push a signed git tag to GitHub. And that tag will include SHA-256 hashes of all the artifacts for reference. And then having done that, we can then kick off the upload of that to some type release, which again is just an own isolated container so the only container that has those privileges here. Equally, the only container that has PGP privileges is here. And we also, in this step here, update GitHub. with like some nice new release notes. So it automatically generates the release notes that we want to see. So that's running along. Just to show you like some previous release. So you've probably seen auto-generated notes like this before. This happens automatically as part of the process. I think these are fairly decent as far as release notes go. You can just see all the pull request numbers there. And I can click into the release for that here, so I can see everything that went on. And there's a link back there to the release notes. So as you can see, you've got nice GitHub actions. We can run a release without choosing our own version number. The version number is chosen for us, and the correct version increment will happen. So this is way better than what we had in terms of like releasing off laptops. And it's, I guess, I would say, more secure as well, because we got all this isolation between the various stages of the job. That's not all though, because we also have support for preview releases. So it's quite often the case that when you're working on a PR and on a library, and you want to try out that library in some like code or staging service, you want to say, okay, here's my PR, here's a library. I want to deploy this to my staging service, and so you need to do a CI build of that service, which means you kind of need to have the artifact handy. So the workflow that we've created supports doing a preview release. So to do that, you just take the branch name of whatever PR it is, and you choose that branch name in here. And now I'm doing oops, is that clicking? Yeah, now I'm doing a preview release. Don't know how many of those I'm doing, a few. So now I'm doing a preview release, and this will do like all the steps of a release, but it will not update the master branch. It will just comment on the PR saying, here's your preview release that you can use and look at if you want to. So this has basically been a pretty big improvement for us at The Guardian. This is rolled out to like 90% of our libraries, and I've got lots of good feedback about it. People really like it. It is a reusable workflow. So if I just go to the repository for it, the workflow is in here. It's an open source repository, and there's a fairly extensive guide on how to use it. I've already use this workflow outside of The Guardian, so it's used on the Scanamo library, so we're releasing using that. And in principle, there's nothing really stopping you from maybe using this workflow yourself if you want to release libraries. The steps of configuration, there's the one-off organization setup where you need to get all those credentials, put them in GitHub secrets, and then there is a sequence of setting up your repository. And as part of the changes, to make them more attractive, we did quite a lot of sort of setting up reasonable defaults that meant that, for the most part, every single PR that introduced this release workflow reduced the size of the repository. It simplified the build SBT, it added a very minimal amount of YAML. So if you have a look at how you invoke this thing here, we're just invoking this reusable workflow. And we have to pass in a few credentials and then the permissions to write to the repository, and that's it. So the amount of boilerplate that has to go with each repository, given the fact there are 40 of them, is quite low, and that's good. That is pretty much everything I wanted to tell you about this workflow. Have we got time for any questions? We must have time for some questions. Any questions? Yeah, hi. I told you it was dead. Oh, right, nice.
I went downstairs and it does not work.
Yeah, sure.
I have two questions. First one. As you said, there's many changes. It's very frequent to break binary compatibility. I think that many times when you think you not, you do break compatibility.
Yes.
I'm quite surprised that in the library that you showed that creating, you're only at the major number of only 5. Doesn't you change? Doesn't it change the major one each time, maybe, or something like that?
Yeah. So the version numbering is based off what SBT version policy thinks. I would say SBT version policy errs on the side of caution, so it is more likely to do a major version number change than, like, sometimes I think maybe it doesn't need to. But on the other hand, numbers are free. Let's just get lots of big numbers. So I think there are some libraries that are up to like version 30 or something, and I don't mind. That's fine, as long as we're safe. Are we okay for time or?
Yes, we're okay.
Oh, okay. Yeah.
You're publishing on Maven Central. You're publishing on Maven.
Oh yes. Yeah.
I saw on your thing that maybe you're also publishing on GitHub packages for your for branches, pre-releases. Does your workflow support publishing to GitHub packages?
That's a really good question. So no, it doesn't. It's only focused on Maven Central. I don't think we've actually done any publishing to GitHub packages. Have you?
Yeah.
Oh, cool. Do you find it good? These are for JVM artifacts?
Yes, they support Maven-style packages, but the trick is you must pay GitHub to have access to the private ones, but fair enough.
Yeah.
But it does work, but you need to use some SBT special plugin to do that. It may be terribly cumbersome, so if it could be done with this kind of workflow, it would be great.
Yeah, that's very interesting. I mean, while I was thinking about how can we make this experience better, I did look at GitHub packages. I couldn't see many examples of setting it up. Yeah, and it's quite nice to be publishing to Maven Central because every JVM thing in the whole world knows what Maven Central is, and I don't know what the support is across the board for GitHub packages. Maybe it's just an additional line of configuration, but it's nice to avoid that. It's good to know that you've had some positive experiences out there. Anything else? No? Okay, well, thanks for letting me talk about it. Cheers.